Okay, we're going to look at oblique impact of smooth spheres. So keeping things quite simple, no friction. And this really does lead on from results that you found already and the stuff we were doing last year on collisions as well. So you're going to have to bear with my circle drawing. I did consider drawing around something and getting a good circle, and I thought it was taking it a bit too far. So we've got two smooth spheres which are colliding, and the reaction between the spheres acts along the line of centres. What that means is if you take the centre of each sphere and join that together with a line, like so, then reaction between the spheres acts along the line. Therefore, the impulse affecting each sphere acts along the line of centres as well. So that when the spheres collide, the impulse from sphere A onto B is going to act this way along the line of centres, and the impulse of B on A will act this way, and they're going to be equal and opposite in magnitude. Let's stick to my colour coding. Coming off perpendicular to the line of centres, you do have a common tangent to both spheres, but I don't think we'll use that particularly in questions, but that's a common tangent. So a couple things to note. The right colour. So perpendicular to the line of centres. So because the impulse is acting this way, perpendicular to the line of centres, so along that common tangent, the component of the velocities remains unchanged. So similar to what you saw when we looked at the sphere colliding with the wall. So perpendicular to line of centres. The components of velocities are unchanged. Anything parallel to the line of centres, then we can use Newton's law of restitution. So E is equal to separation speed over approach speed. We can also use conservation of momentum. So we're going back to using both of those. So these questions aren't dissimilar to the ones you did last year when you had two spheres or objects colliding, but the only thing we're doing is we're making the collisions so that one of them's at an angle, so that they're oblique instead. So it just makes it slightly harder, but the principle's the same. So for your notes, parallel to the line of centres, so we have Newton's law of restitution, and also conservation of momentum. And so they're the things that we're going to be bringing into questions. So perpendicular to the line of centres, components of velocities are unchanged. Parallel, then we're using Newton's law of restitution and conservation of momentum.